Get your 3D glasses on now because this is the Russell Brown Show. And in this tutorial, I'm going to be demonstrating how to work with 3D models here inside of Adobe Photoshop CS4 Extended. My final project will be to create a lenticular image as you see here. We're going to take our 3D models and our 2D background, combine them together to create this lenticular image. Incredible! Okay, let's get started. I'm going to go directly over here to my original files and start this whole project and show you how to do this step by step. I'm going to start here with this 2D image, as you can see here. And here, if I go up to my image menu and down here to image size, you can see that my project is starting out at 9 inches in width, 12 inches in height at 150 pixels per inch. That's a great resolution to start at, by the way. Canceling from that, let's get started. So as I said, I need to turn this 2D layer into a 3D layer. I'm going to target it here. Then I'm going up here to the 3D menu and down here to New 3D Postcard from Layer. Selecting this will now turn this into a 3D item. I know that it's a 3D item because here, in this case, I've selected the 3D Rotate tool from my tool panel. And if I click and hold and rotate, I can now see that this is indeed a 3D postcard. Okay, check this out. If I hold down the Shift key and then click, I can constrain this to a horizontal axis as you see here. And what I want to do in this project is to angle this back to enhance the forced perspective which is already in this image. So by angling this back, I can then enhance this whole process of lenticular imaging. What we need to do now is to actually turn on a new feature called Anaglyphic Preview, where I can actually see how this might behave on my lenticular image. To do that, I'm going to double click here on the thumbnail for my background image, right here. This will reveal my 3D scene panel. And of course, you can always reveal your panel here from the window menu and down here to select 3D. I might also suggest that you select the workspace called Advanced 3D before you start a project like this. Okay, moving on. I'm now going to click here on Render Settings. It's going to target that particular layer, and this dialog appears right here. If you have a pair of 3D red-blue glasses at this time, it would be a good time to put them on. If you don't, well, just follow along. I'm going to click here on this checkbox to enable stereo rendering. The first thing that happens is that the default red-blue stereo rendering setting appears here. Next, I want to talk about these two settings, parallax and focal plane. And if you have not watched my basic tutorial on working with 3D lenticular imaging, that would be great to do that first. But once again, let me tell you that parallax represents the distance between the stereo cameras. And as I've said before, increasing this value will then increase the dynamics of the 3D effect. For 3D postcards, I'm always recommending about 30 for my parallax. It really gives me great dynamics and gives me a full range of focal plane settings that I can set over here. Now check this out. If you look up here at the top here at the clouds, they're a little bit more offset than they are down here in the trees. That's because I'm angling this back and the clouds are farther away, thus enhancing the already forced perspective in my image. If I click here on the word focal plane and hold, I can then move to the left and decrease this with minus values and push this back into my image like this. I can also click once again and move to the right and add in positive values to bring it forward. With your glasses on, you can then clearly see how this is moving back and forward based upon these negative or positive values. Okay, that looks good right there for now for this positioning of this background image. I'm now going to click OK, because now I'd like to introduce you to working with 3D models. Let's close this down and let's bring in a 3D model. The best way to do this is to go up here to the 3D menu and select New Layer from 3D File. And in this case, I'm going to be opening up a collada file right here of my dinosaur. Collada is a great format. I also use U3D as well. I'm going to click Open. And of course, this model was generated from an application called DAZ 3D Studio. I exported it from DAZ and then can bring it directly into Photoshop. It's a great library, by the way, of fantastic models that you can work with inside of Adobe Photoshop CS4 Extended. Okay, there's our model. I need to work on this. Over here in my tool panel, I think what I'd like to do first is to select this tool, the 3D Scale tool, right here. With this selected, I can click and drag away from my dinosaur just like this and increase its size right like that. Then once again, I could select one of the other tools here from the tool panel, but don't forget you also have these tools available up here in your options bar. And in this case, I want the drag the 3D object tool right there, and I can move this around. Of course, selecting this tool will not change its size, but only its position, just like this. Let's line this up right there, just like that. Next, I want to show you that I have a second 3D item that I've already imported, and it's my dragonfly right here. I'm going to turn that layer on right there, and I will also demonstrate that yes indeed, this is of course a 3D item as well, and I can rotate this around just like this. Okay, let's now talk about working with 3D models. I'm going to zoom in here on this dinosaur because I want to demonstrate a great new feature that allows me to blend this 3D model more gracefully into my surroundings, in this case my background of trees. So I'm going to target my dinosaur in this case right here. Once again, I'm going to double click here on the thumbnail, which will reveal the 3D scene panel. Within this dialog, you have a series of icons here at the top. The one I want to look at is right here. It's filter by lights. I'd like to demonstrate now how you can adjust the lights of any 3D object. Now when you import a 3D object from DAZ Studio, it has lights that are already applied to that model, and those lights are directly imported in. You can also add lights here, you can delete lights, and you can actually replace all your lights with a set of saved preset lights. Some great new features. In this project, I just want to show you how to adjust the lights. I'm going to select this light right here, my infinite light number 2. And in fact, if I pull this down here a bit, you can see that I actually have 3 different light sources. I know that infinite light number 2 is my main light source that represents sunlight. And that's why it's called the infinite light, because the light source is infinitely distant from the dinosaur. Okay, with that targeted, I then move down here and I select this icon right here. Rotate the light. A great new feature. Check this out. I move into my work area here, and in fact I'm going to close this down so we can see this more clearly. I'm clicking and holding, and I can now start to move this light source around. Check it out. So I'm moving the angle and direction of the sunlight, just like this. It then adjusts how the shadows fall on any 3D model. So it's a great way to bring in models and adjust their lighting to match your scene. And in fact, you can even bring in, as I said, additional lights or delete lights. A great new feature found here in CS4 Extended. Okay, let's continue our project. What I want to demonstrate now has to do with converting this into a lenticular image and working with models in this process. I'm going to zoom back out a bit and take a look at our entire scene just like this. Now what I want to do next is talk about adding lenticular 3D effects to models. Of course, 3D models inside of CS4 Extended have all the properties of 3D built into them already, and we can draw on that and use that in the process of creating a lenticular image, and that's what's so fantastic. Here in this case, if I double click here on the thumbnail for the dinosaur right there, I can bring up, of course, my 3D settings here under my 3D panel. And in this case, if I click on this icon right here to filter by whole scene, I can then go down here again and select render settings. just like I did with my 2D item in the background. If I click on render settings, you can of course down here enable the stereo rendering, and then the red-blue default appears here. And in this case, when working with 3D items, my recommended value is a parallax of 20. A value of 20 for my parallax seems to work really well. This whole process of working with parallax and focal plane on a 3D model is quite different than how you would work with a 2D model. So let me stop right now, and I'm going to open up a special graphic that will help explain this whole process. Let's go to that graphic right now. Okay, here it is, a fantastic 3D graphic that's going to help you better understand how parallax and focal plane work on a 3D object. Of course, we know that with a 2D object set to a 0 focal plane, it sits right on that focal plane. And of course, if we were to adjust this and add in a positive value, it brings the item forward. But it doesn't have any depth, and it doesn't work quite like a dinosaur. So let's check this out. With a 3D dinosaur or any other 3D object, the focal point of 0, the default, goes right through the middle of any 3D item. If we were to create a lenticular image of this, the entire central region of this dinosaur would be in sharp focus. But that may not be what we want. We may want the eye to be in focus. So what do? We can move the dinosaur in a negative value with the focal plane back. So focal plane adjustments, a negative value of a focal plane adjustment will push the dinosaur back into space like this, moving this sharp focal plane to a new position lined up with your dinosaur or any 3D object. So you control where the sharpest focus is. Now keep in mind, with the setting of parallax, there's going to be a fall off of focus going forward and back. As I said, the higher the value you use for your parallax, the less focus you will have across your image. And in the case of a dinosaur, you're going to lose focus back here at the end of his tail if you use a parallax setting that's too high. My recommended setting for working with 3D objects is somewhere around 20 for your parallax. And of course, if you use a positive value on your 3D object, it then brings your 3D object crashing forward, jumping out of your 3D art, and it's moving the focal plane back, though, to the tail section of your dinosaur in this case. So positive values forward, negative values back, and of course the default is set at 0. One more thing about parallax. You may have noticed that I'm using different parallax settings for different objects in my scene. It's okay. You can set the 3D objects with a parallax of 20, and you can set the 3D postcards with a parallax of 30, and they can live together in harmony. Now you know. Okay, I think this will be helpful when you're working with your project. Let's close this down and go back to our project now. Okay, let's use what we've just learned and apply some parallax and focal plane settings to our 3D models. I'm first going to start with my dinosaur. Here in my Layers tabbed panel, I'm going to double click on the thumbnail to reveal the 3D scene panel. Then of course, down here under Render Settings, this is where I can make my adjustments. And I want to check this box again, the Enable Stereo Rendering right there. Okay, what did Mr. Brown say? He said his recommended parallax value for 3D models was a value of 20. And of course, he should also tell you that you should run experiments of your own on your particular lens to make sure that you come up with your recommended value. But this is a good starting point. So I'm selecting 20 for that value. I'm now going to reach for my 3D glasses because this is really beneficial to set this up in this 3D anaglyphic mode because you can preview it this way. So now I'm going to click on focal plane over here. It's currently at the 0 value, and I'm going to start to move this to the left with the scrubby sliders and drop this back into my scene. Now as I look through my glasses, I can see this dropping back into the scene just like this, and that's looking pretty good with a negative value right there. And of course, as I move this back, it's pushing my focal plane back, so I have to be careful where my focus is on this item. That looks great. I'm going to click OK and move on to my dragonfly. Right here, selecting the dragonfly, once again bringing up the render settings, turning on and enabling the 3D stereo rendering, and then once again let's set the dragonfly to a parallax of 20 and then adjust its focal plane. Once again, it's really important to put on your glasses at this time because I want that dragonfly to look like it's inside the mouth of the dinosaur. So I'm actually giving it a positive value and bringing it forward slightly, just like that. There it is. That looks great. I'm now going to click OK once again. So we're getting really close to finishing this project. We've got all of our settings, in this case for my background image, my dinosaur, and my dragonfly looking great. I'm now going to close this window down and start to prepare this for my final printed lenticular project. The next step is to crop this image down to a size that matches my lens. And in this case, I'm targeting a micro lens, 40 line per inch, 8x10 lens. So let's start with the size. Here under the image menu, I'm going to go down here to canvas size right here. My final canvas size needs to be set to an 8-inch width and a 10-inch height. Now remember, I'm using canvas size to do this because I do not want to crop any of the image off. Whenever you're working on a lenticular project, you want to make sure that your 3D models and your 3D postcards stretch out beyond the borders. I'm going to click OK. Proceed forward because the canvas size is changing. Now, when this crops this down, I can then readjust things to make sure that they fall within my work area. Especially in this case, my background. Targeting my background, I'm going to adjust this. Over here, for my tool panel, I'm going to select, in this case, my 3D scale tool, so I can scale this up a bit. Clicking here in the center, then dragging away from the center should scale this up. Make sure you scale this up till you completely fill the frame, just like that. Okay, that's looking great. It's now time to interlace our image and prepare it for the lenticular printing process. To do that, once again, I'm going back into the render settings. I double click here on the thumbnail for my background image once again to reveal the 3D scene panel and render settings. Down here under stereotype, we switch from red-blue to vertical interlaced right here. And down here, you'll notice that I now have a field called lenticular spacing. As I said earlier, I'm using a 40 line per inch lens. So I'm entering that value in here. You can enter in any value for your target LPI lens, but you cannot enter in a fraction. Now, if you need to adjust your lenticular spacing or LPI for your lens, you will do that after you've completed this initial process. But you first must put in this integer value. Okay, now you know. I'm now going to click OK right up there and move to my dinosaur 3D layer here and do the same thing. Bringing up my render settings, adjusting this to vertical interlaced, and then clicking OK. Let's move on to the dragonfly and do the same thing. So I simply go from the red-blue phase right into the vertical interlaced phase, right there. And I click OK, just like that. That's it. I have completed this process and I have turned this into an interlaced image. Of course, if we zoom in on this, we can see the interlacing on each of our individual layers, just like this. But wait, there's one final step. You are not ready to print this yet. A very critical step is next, and that's to size this and to adjust its resolution. The best way to do this is, of course, with the crop tool over here in my tool panel. As you can see up here in the options bar, my width is 8 inches, my height is 10 inches, and in this case, I'm targeting a printer that needs a resolution, a default resolution of 600 pixels per inch right here. And in this case, I'm targeting an HP printer. This same value would be used for a Canon printer. But if you're using an Epson printer, this value would have to be changed to 720 pixels per inch. Just so you know. Very, very critical though. My target printer is 600 pixels per inch. I select that. Then I can go in here, click and drag over my image area just like this. Cast your eyes up here. You must select Hide up here in the options bar. You do not want to crop off the area of the image which bleeds out to the left and the right. It's very critical that you hold on to that information in this lenticular process. So I've checked this button right up here, Hide. Now you know. I double click inside the image area right now and it will start to crop this and resize this to the settings that I selected. Okay, it's done. Now remember, due to the complexity of this interlacing process, this conversion, this resizing, can take a bit of time. So be patient. I'm going to zoom back out on this and look at our finished piece right there. It is now ready for printing. We could go to our print dialog and print this. My recommendations are that you print this on a very high gloss stock of paper whenever you're trying to do a quality interlaced project. It's the best paper to use. There you have it, another great new technique for working with 3D objects to create lenticular images here inside of Adobe Photoshop CS4 Extended.